This is a stock WEN GN625i, and it's a gasoline only generator right now. The reason I have this is I'm going to modify it for my neighbor to tri-fuel, and also going to modify that one. And then down at the end here is mine, which has already been modified. Okay, here I have my tri-fuel setup using the OEM carb, and then these are still set up for gasoline. And the donor carb is a dual fuel carb for a GX390, and just gonna rob some parts off of this to modify the OEM carb. Now the thing that we are doing is we're using these in 120 volts, and the only way to get 120 volts at the full amperage, which is slightly over 40 amps, is to change out this TT30 for a, here we go, it's a 1050R, which is a 50 amp plug. And you also need to change this breaker out for a 40 amp breaker. And that way you can get the maximum capability at 120 volts through this plug. The only way to do it in its stock condition is to use a combination of either a TT30 or the standard 120 volt plugs. And that's a lot of extension cords to run. So coming off of here, we have just changing this out, we have just one plug to use for the entire capacity of the generator. Okay, so this one has never been run. I'm gonna have to do a break-in on that and do the modifications. This one has been running just fine on gasoline, and it has the plug already changed out and has been working just fine. The plug goes into the house panel through an interlock breaker and feeds both sides of the panel with 120 volts. That's in phase, so that means none of the 240 volt items in the house will run, but we are good with that setup because we run off natural gas. So we still have heating with the furnace, we still have hot water, and we also have put in mini splits that run off 120 volts. So that will provide some air conditioning because we can't run our 4-ton 240 volt units off of this. It's just a little small for that. So getting these things modified will get us tri-fuel, which again, we have natural gas, so that's what we've been using, or what I've been using. These two have not been modified yet. In fact, this one has never been run. But get these modified for tri-fuel, and then they'll have propane and natural gas options instead of just having to stick with the gasoline. So I guess the next thing to do here would be to take the carburetors off of this. I've also made some other modifications, which maybe I'll tell about it in a video. Brought my pull rope up front And I also put a little bit of a safety on here to make sure this never gets switched over to 240 volts. Just bent up some metal there to help prevent that. And this breaker has been changed out for a 40 amp. Okay, well, I will be taking these carburetors off of these two and showing how to modify those. This video may be a little bit broken up because of what I have to do, but anyway, this is the start of it. And so off we go. To begin this process, we've got to get the parts off of the dual fuel carburetor that we need to modify the OEM carb. I don't know why they call these a dual fuel carburetor, because they're actually tri-fuel. But anyway, we're going to begin by taking the demand valve off, because you obviously need that. Okay, we can put this aside for now. Then we need the fuel spud. I'll grab it with some pliers and twist it out. Don't have to worry about the plier marks on it, because we're going to grind all that off later. It's just held in with some epoxy. Okay, so that's what it looks like. And this is for a GX390, so it's got pretty good sized orifice in it. Okay, we'll set that aside. We will not be using the fuel solenoid. Okay. We will be using the carb bowl. Okay. Next, we're going to modify this bowl, because we have to use this bowl on the OEM carburetor so that we get the drain. And to do that, we need to cut this off because it interferes with the air cleaner, and I'll show you that. Okay, on the modification of this bowl, when we get the other carburetor modified, it's going to be turned this way. And this drain has to be removed because it'll hit the air filter. So I recommend that you modify this bowl before you take the carb off of the generator. And get the bowl where it'll fit. Okay, and we're going to be needing this. We're not going to be needing this. Okay, you see if I turn this around, it won't even go in there because that's hitting the air cleaner. It won't go on. So what I'm going to do is I'm going to cut this off. Also going to cut off this bolt and use it as a plug. But just cut it off as close as I can, about in here, and then take a piece of this bolt and use it as a plug with some epoxy. Plug this off because we don't need it. It'll be around to the back. Okay, I'm back. All right. Here's the bolt. I cut the head off of it. But before I cut the head off of it, I made a slot in the end so that I can get my screwdriver in here. I don't know if you can see that. Okay. And this becomes, of course, after I cut it off of the bolt, this becomes the plug for this. I've cut it off, and we'll put epoxy in there later to make sure this stays in place, but I can see if it fits. Hopefully it still does. Oh yeah. Oh yeah. Look at that. Look at that. That's nice. Okay. Now you can screw that into the point. If you screw it in too far, then you'll end up blocking the drain. So I've got to be careful with that. Now one thing I've noticed here, let me get this out of here. Okay, I'm gonna put that in there because I'm going to be using it. Don't need this. Pointing it wrong. This hole does not go all the way to the bottom of the carb. And that's going to prevent some residue of gasoline remaining in the bottom of the bowl when you drain the bowl. So what I'm going to do is I'm going to drill this out so that we get complete drainage of the bowl. So let's see if we can do that, or if we're just going to totally mess this thing up. There we go. All right. Now we've got a hole that goes all the way to the bottom of the bowl. Should drain well. There we go. Okay. All right. So now it's time to get the carb off of the generator. To get this carburetor off, of course, remove the breather tube. There's two number 10 nuts inside the air cleaner that bolt the air cleaner onto the carburetor and the carburetor onto the engine. And then there's down here, there's a number 8 screw that holds the bottom of the air cleaner box. Of course, you got to remove your hoses, your choke mechanism, which is up here. Have to remove this, and going to have to remove the servo motor off the throttle. Now the reason that, let's see if I can get this light over here. One of the reasons that we had to go with a modified OEM carburetor is because on this particular gen, you cannot, you cannot put an adapter on the back. Let's get this thing out of the way. You cannot put an adapter on the back of the air cleaner between the carburetor and the air cleaner box because of this distance right down here. If you try to move this air cleaner forward by using an adapter, you're going to run into an issue right here with this particular generator. Some generators you run into a problem, you know, here with this frame, but on this generator the problem's down here. Okay, so let's see what we can do here. Okay, to get the carburetor off, I have to remove the choke cable, which I've already loosened up these 2 screws here. Okay, pull that out. This is clipped in here at the bottom. See that clip right there? And then 2 screws in here to hold the servo motor on. And then I'm not going to show taking the air cleaner off because that's pretty obvious. Take the air cleaner off, two number 10 screws holding this on, and like I said, the number 8 down here at the bottom. So we'll proceed from there. Okay, got the carburetor off, and first thing you probably want to do is get rid of this float and needle assembly. Okay, you can leave the bowl gasket on there or not, whichever you want to do. Okay, we're going to take the choke off of it and pay attention to how this spring is wrapped around here. When we put this back together, we're actually going to wrap it around this post instead of this post, because our fuel spud is going to go in here. Anyway, just take pictures, whatever you got to do to make sure you get this spring back on here correctly. Okay. And off comes that spring. And don't lose this little washer right here. In fact, I think I'll get some tape and put on here so that I don't have that fall apart. Okay, then next is let's remove the choke mount. And then the servo mount. Now on this servo mount, right in here is a little spring. And you don't want that flying across the room. So just be aware of that. Okay. All right, there's that spring. Again, I think I'll get some tape and tape all that together. But now we should have the carburetor down to the point that we can put the fuel spud. Because this guy is going right in here. I'll be drilling a hole for this through here. Alrighty, I got this drilled out so that this can drop right in here. I also went ahead and filed this post off a little bit. Hope you can see that. If it'll just focus. Okay. And the reason I need to file this post off is because this copper tubing 90, this is a 1/4 inch 90, it has to go right here. And so it needs a little bit more room than that hole. Now, to drill that hole, it's really convenient that that thing had a dimple in it because it's in a perfect location. Just start with a, I think I started with a 9/64, and it, because of that dimple, it centered itself, and then you end up with a 19/64 for this to fit. All right, and I'm not gonna do any more with this right at the moment. Also put some tape in here so that you don't drop debris down into the main jet while you're drilling a hole. But the reason this works out so great here is because that's in a very high vacuum area. The closer you get to the throttle, the higher your vacuum. So in this carb here, for example, the fuel spud is up here at the front. It's actually before the narrow part of the carburetor body. As you get further back into the carburetor, the higher the vacuum. Now, obviously, you you can't inject behind the throttle because you'd have no control over the amount of fuel. Now, some manufacturers actually put the fuel spud back here, right ahead of the throttle. But that's in a very inconvenient location for this particular machine. So up here at the top is a great location. If you don't happen to have that dimple that was in this carburetor for my GN625, and you have a carburetor that's like this, which you'll find on the GN825, you'll have to flatten this off with like a piece of aluminum, epoxied on here, and then drill a hole for your fuel spud and this 90-degree elbow. Well, I may show that later. Okay, so that's as far as I'm going with this part right now. And I need to get this mounted to the bolt. Okay, when you put the fuel spud in here, you notice it comes way down inside the throttle body. Well, you can't have that. It's going to have to be up to here, so we'll cut this off. But the first thing I've got to do is make this fit inside this 90-degree elbow. And to do that, I've got to do two things. I've got to grind it off so that it will physically go in. Let me get that out of there. Okay, we want this to of course, physically go in here, but you notice I also need, get this out of the way. In order for this to line up with the demand valve, I want it at a slight angle. So it's not sitting flat like this. It's, golly, get the lighting on everything here. Okay, maybe this will help if I do it this way. You see, if it's sitting flat, it doesn't line up with the tubing from the demand valve. So I want to put this in there at a slight angle. And so I'm going to slightly grind this at an angle that will go in here and sit at an angle. I'm exaggerating here, but it has to sit at an angle like this. So I'll go work on that next. Okay, I've reassembled the demand valve onto the carburetor temporarily and also mounted it to the generator, just with the screws hand tight on the air cleaner. The reason for doing that is to determine the position of the demand valve, because you want to make sure that you have this centered so that you're clearing the air cleaner and the engine. And then tighten the the bolt for the carburetor down so that it maintains that position. The reason you want to know that position is, okay, here's the fuel spud. I went ahead and soldered it into the elbow and a piece of 1/4-inch copper tubing, solder coated everything just to make it look nice. Okay, the reason you want to know where to position the demand valve is because you want to, when you get this guy in here, you want to line up with the demand valve, and then you'll be able to finish off epoxying the fuel spud in there after you shorten it, which I'll show that next. One more thing I'll mention while I'm here is the breather tube. It has to fit over the top of this tube here, and I'll show you where I angled this down just a little bit to help this situation. I could always put in a longer breather tube if I needed to, but just to not have to do that, I think I'll try it the way it is. So now that we have the fuel spud in the correct position here, and I've marked where the carburetor bowl is to be positioned, the next thing we have to do is to cut the fuel spud off. And to do that, okay, what we want to do is mark where the top of the carburetor venturi is on the front, and then also on the back of the fuel spud. Okay. Alrighty, and then one last thing is to line this up with the demand valve and to mark the front face oh, that didn't come out with a flip. Let's see. Okay, now I've got a mark on it. So there's the front of this fuel spud. So if we take that out and look at it, this is the top, and here's the front. So what we want to do is we're going to grind this fuel spud off, but we're going to do it at an angle. And I'm going to come down 2/10 of an inch. Okay, which will be right here. And then this is going to be ground off at an angle from here back to at least where the top of the, you see the mark there? It's going to be ground at an angle like that. So it'll hang down inside the carburetor 2/10 of an inch on the leading edge, and then it'll be even, or even it can be above. It doesn't matter much. And you'll see now why I put the holes in the fuel spud going crossways with the carburetor, so that I wouldn't be having a hole exposed here. All right, so we're going to go off and grind this puppy off, and proceed with the project. Okay, I've got this ground off, and here's the mark I made for the top of the venturi in the carburetor, and then I measured down about 2/10 of an inch, and I ground down to where the line disappeared. So overall I have about 1.75 inches. The top of the carburetor is just above that line, and you see that's right at about, if I can get up here closer, it's right at about 1.75 inches. Okay, anywhere 0.15 to 0.175 should work just fine. Okay, so this is gonna go into here, and then you can see, hopefully, if this thing focuses, there's how it sticks down inside the carburetor, just right here. All right, so first thing you want to do is clean that off with some alcohol and make sure that there's no oil residue or anything like that on it. Okay, that's looking really good. We'll clean around this hole. Okay, it doesn't look like anything's coming off, so that's good to go. And then I'm going to clean around here, even though that should already be clean. Okay, so now the reason we're grinding this off like this is, if you look at what's happening inside the venturi of the carburetor, or some people call it the throat, same thing, which is the area between here and here, is this is a high vacuum area, and as the air comes in from the air filter, goes through the carburetor out towards the intake of the engine, the vacuum increases as you get closer to the engine, but you can't go beyond the throttle, of course. So you have to be somewhere between the throttle and preferably inside this venturi. Now, some carburetors come, let's see, all right, as this one did, the hole for the fuel spud was just barely, you see it coming through there, just barely inside the throat of the carburetor. And I have seen some of them that are actually further out into this area. But again, the closer you get to the throttle, the more suction you have, more vacuum, and that improves the response. It doesn't necessarily improve the ability to deliver propane or natural gas to the engine, but it, in terms of just steady running, but it increases the response to throttle changes. Okay, so this shape I got from a Weber carburetor. Of course, now it was gasoline, but they had put about a 45 or so degree angle on their emulsion tube, which of course the emulsion tube come out here on this carb for the gasoline. But the idea that I think Weber was using was when air passes past this, it will create a little bit of turbulence here and travel on, but that turbulence probably increases the vacuum. I can't prove that, but I mean, I don't have the equipment to prove it, but I did my testing and it worked really well. And so I'm not going to try to improve on success. The spud coming down inside the carburetor, if you stay within the 150 to 175 thousandths range, it appeared again through my testing that it did not interfere with gasoline operation, because remember, you're taking up part of the throat area when you stick this thing in there. You're taking up part of the throat, and you want to be careful about interfering with gasoline operation if you're still trying to maintain gasoline operation. And speaking of which, okay, some of the modification kits or conversion kits that you get, they put between the air filter and the carburetor, they put a venturi here. Something like this. I'm exaggerating it for effect. So when the air comes through here, you get higher vacuum in this area. Now the problem with this, those kits that put a venturi here in front of the carburetor, well, number one, it moves the air filter out, which I can't do on my generator because the air filter hits that bracket. But the other problem is these venturis, even though they work fine for your gaseous fuels, LP and natural gas, is they often interfere with gasoline operation. So, and they'll even say that on their website, on most of them that have the venturi set up. This venturi interferes with gasoline operation. So that means if you have a situation where you've run out of your propane, for example, and you need to put gasoline in the generator to keep running during an outage, well, now you have to go out there and remove this venturi to put it back in gasoline mode. And that's certainly not ideal in the middle of a storm or something like that where you're having to run the generator. Okay, all right, so before I jump back over to this carburetor, I did mention that I was going to talk about alternatives to putting it in the top of the carburetor the way I did, or if you have a different carburetor, such as this one that doesn't have that nice little dimple in the top. Okay, here's a piece of 1/8 inch aluminum that I just kind of quickly hacked out. Didn't really try to be too careful here, but the idea is we would epoxy this in place, and then we would drill our hole through here for the spud. Now there's another option. Okay, let's take this out for a second. There's another option. Okay, I just drilled a hole through here all the way through. inside, and the fuel spud could be put in here. You're missing the stud that mounts the carburetor, so you've got to probably come in at an angle. Let's see. Okay, so if this is your stud, you see I'm still missing the fuel spud with the stud, and then you can put it in about like that. And you see on the inside of the carburetor, we have this going on where you'd have to put epoxy here. Now there is a hole that vents the bowl. Okay, it's right here. And you don't want to block that vent. If you do, the carburetor is not going to work correctly. Now, let's see, where'd my spud go? All right. So here I have put some tape inside here because I want to be able to fill up these holes, but not fill up the spud with epoxy. So it would go in something like this. Okay. Just so that it pops out the end like so. Yeah. And you, of course, epoxy all around both sides. You probably have to twist it as you do it to get the epoxy. This thing is not focusing. Okay. You'd have to spin it and so that you get the epoxy all the way around this, and then let it sit in place while it dries. And again, if you do happen to drip down and plug up that hole, just drill it out. That would come through here. And you see it would be here. Okay. So there's two options. Do something like this. And the throttle butterfly does not hit that. Let's see. You want here with the throttle stuff. Okay, here we go. See, the butterfly closes this way, so it does not get back into here. So no problem with the throttle. I just removed it so that you can see it easier here. And then after it gets, the epoxy sets up, then you just rip these pieces of tape out and your holes will be closed up. Okay, so back to this guy. This piece of hose is from the hose that I bought when I converted my generator. I bought a kit off of eBay that was an open box, and it came with the conversion carburetor and a hose and a regulator. All right. There's about 3 foot of this hose in that kit. I believe this is actually silicone hose, but I don't know for sure. The hose is not marked, but it's 3/8 ID. Silicone's probably not the best to use with natural gas, but I rarely run my generator, so I'm not going to worry about it if I have to replace this. Okay, your Your nitrile rubbers and things like that are better suited for natural gas. Okay, so what we're going to do is have some epoxy mixed up. We're going to put it around here. Try not to get it in the holes. Okay. Stick it down in here, give it a little bit of twisting action as I go. Put this on here. And down on here. Okay, and then line this guy up properly. There we go. Okay. And we're going to spread this all around here really good. Our choke is going to stop right here, so I'm going to kind of shave that off a little bit. All right. Got a little bit on the throttle body or throttle control there, but that's plastic. That'll come right off. All right, that's good enough. Okay, and then while I have the epoxy mixed up, we're going to put our plug in here. I'm going to put just a little bit, not much, because I don't want it plugging up the drain. Okay, looks pretty good. Nice and tight. And I'm going to cover over it. That is sealed. Okay, now we just have to wait for the epoxy to cure. Okay, I ended up with enough epoxy left over. I'm going to go ahead and show how to put this aluminum on the top of this so this style carburetor can be used. Just be generous with the epoxy. Okay. I'm going to put a little bit more on the back of this. Okay, like I said, I'm trying to be generous with it. Okay, push this down in place. All right. That looks pretty good. Could even use some more epoxy on there, but this is just for demonstration purposes. Okay, so your elbow would fit right here. So you mark this out and find the center and drill your hole. And that should be as good as the other carburetor that had the dimple in it. Just not as convenient, but it'll still work. So you can put the spud down through the top or put it into the side. Either way. Hope that makes sense. Okay, the JB weld is all hardened up now, and one last thing to do to this carburetor. Well, actually two. I noticed this is drain hose is too long. It's got a loop in it, so I'm going to cut this off, but that's a minor deal. The thing that we need to do is to put a screw into the fuel spud. Now, the reason we got to do that is because this fuel spud is for a GX390, which is a much larger engine. So by putting a screw through this portion of it right here, which would be here on the assembly, what you're doing is using this screw to close part of the fuel spud off. And this fuel spud is an orifice, and they Typically on these conversion carbs, they match the orifice to the engine, but this is for a GX390, like I said, and besides, if I did have an orifice on the end of this to match the engine, I'd be cutting it off anyway to put it in this carb. So I have to basically choke down this fuel spud to not flood the engine and be within the range of these two adjustment screws right here. Now, I can try a number 10, for example, which is this, and that seems like that's way too big. So I can do a number 6, and that seems like maybe a little bit too small. Okay, or I can do a number 8, which is this right here. And that's what I'm going to do, because that's about right. It gives me lots of adjustment if I screw this in till it bottoms out on the other side. So we're gonna drill into this portion right here, and I'm going to put a mark on there to where my screwdriver clears the plumbing here for the fuel. And you got to keep in mind the air cleaner sits here, so you want to be able to get in here. So somewhere right about in, looks like here. Okay, that would work. And then about the middle, I remember this part of the fuel spud is up inside this copper elbow. So about maybe here would be halfway. That way I know I'm grabbing a good amount of brass to make my threads. So I'll be doing that, and I went ahead and drilled a hole in this carburetor just to show you. After putting that on there, I drew around, where the copper elbow would go, and then I found the center of that, or close to center, and then drilled a hole for the fuel spud there. So there's another option, okay, for a carburetor that doesn't have that little dimple in the top that was so convenient for this carburetor. But and then of course you'll cut it off to the right length, similar to what we did on the carburetor. And again, you have the option. Let's take that out of there. You have the option of dropping this in here and epoxying it about like that. Okay, so off to drill a hole for the drill and tap a hole for the screw in this assembly here. And speaking of why we need to choke that down, if you look at the demand valve and how it comes, now this comes with LP and natural gas settings, okay, that are you can adjust which fuel type you're using. And then they have the screws in here which allow you to screw into here and kind of trim the air fuel mixture to the correct setting. Now, the reason they have two settings is, again, The two different types of fuel require a different orifice. If we look at here at the LP setting, see how I have this set on LP, and if you look at the orifice size that's down in there. All right, here's a 3/16 drill bit, and it's just almost it's a perfect fit down in there. All right, and then if I switch it over to the natural gas setting, okay, you'll see that's much bigger. And this is a 1/4-inch drill bit, and it fits right in there, okay, for the natural gas. So that is almost exactly a 2-to-1 difference in orifice size here in the demand regulator. And see, 3/16 would be 0.027 square inches cross section of that orifice. And then the 1/4-inch would be 0.049. So darn near exactly twice. And the reason the orifice sizes are different is two reasons. One, the BTU content of LPG and natural gas are completely different. They're roughly 2-to-1, LP being about twice the BTU content. But the other thing too is they're delivered at different pressures. The the water column pressure is about 11 inches for LP standard. And then for natural gas, it's 7 inches of water column. So you've got a significant difference there in the pressure and the BTU content, and therefore you need a different size orifice to get the correct fuel air mix. One other note, these are called demand valves. They're also called zero governors. There's a few other terms, demand regulator. I hate when manufacturers refer to these as just a regulator, because regulator can get confused with a pressure regulator, and these are not pressure regulators. These are flow regulators. And one of the reasons they call them zero governors is because if there's zero vacuum here on the outlet, then zero fuel will flow through the demand valve. The demand valve also serves as a safety device. In other words, should your generator die for some reason, let's say it runs low on oil, then the engine would quit. And if you didn't have a demand valve or zero governor, you could have fuel flowing out into whatever space the generator's in. And that could be dangerous depending on where you have the generator. Now this demand valve happens to have a primer button on it to get the does two things. It helps clear your line when you put your line on here. It helps clear the line of air, so that when you go to start the generator, you have your fuel available here at the demand valve. But the other thing it does too is it's just like a primer bulb. Let's say on a lawnmower, you push this and you get fuel into the carburetor so that you can start the engine. I don't happen to use the primer bulb function very much, or primer button function very much. I just usually choke my generator. Does the same thing. Okay, so off to drill a hole. Okay, here's the carb reassembled. I've got the number 8 screw drilled and tapped into here, and when I go to adjust that, I will put Loctite on it. Now, you could use a jam nut in there if you want to do that. It really makes no difference, but I put Loctite on my other one. It seems to work fine. But that's going to be the coarse adjustment, and then the fine adjustments will be here. And I'll put that in a different video, how to adjust this. So look in the description for the link. Okay, now, I mentioned earlier that you have to wrap this spring for the choke around this post instead of around that one. And then also make sure that the choke fully opens, that you haven't put some JB weld or something here that's going to prevent this from fully opening. That's good. And remember not to let this spring get away from you when you're reassembling this. Now, I did go ahead and put blue Loctite on all the screws. It's for the choke cable and the servo mount. And also I cut a little bit off of this so that I didn't have that P-trap action going on. Okay. And don't forget about that little washer that goes right here. Let's see. All right, that's it. It's ready to go back on the generator. A few more things to note before I close out this video. One of them is I changed the angle. Let's see if I can get both of these in here. I changed the angle at which I drilled the hole for the spud in the top of the carburetor. The reason being is the breather tube that goes between the engine valve cover and over to the air cleaner. It's really tight, and that's one of the reasons I did angle this one a little bit, but I did it by first drilling this hole at a 90-degree angle to the carburetor, and then I tilted the fuel spud just a little bit when I put it in. And that makes the breather tube, well, I would say it's okay, but it's not ideal. So when I drilled this hole, I tilted my table on my drill press to 10 degrees. And see if I can get these up here. You can see a significant difference between the two. This one being much further down, and the breather tube easily clears this one. So that is going to be my recommendation going forward, is that drill that hole at a 90-degree. Instead of a 90-degree angle, drill it at a 10-degree angle. Okay, now I haven't fully assembled this, so don't pay attention to that. And you can see, by the way, you can see the fuel spud down in there, hopefully. There. Okay, and then let's see, I had to also put a very slight bend because I tilted this 10 degrees. I had to put a very slight bend here in this bracket, and you can see it's not 90 degrees. Get that up there. I don't know if you can see that gap or not, but it's off just a little bit from 90. This bracket is just factory, and it's dead on 90 degrees. So I did that so that the demand valve would more or less line up with the fact that this is bent. Or not bent, but angled. Okay. One thing I'd like to get some commenters to recommend flexible hose. I do believe that even though this hose was shipped with a conversion carb in a kit, again, it came with this regulator. Nothing fancy about that regulator at all. And it just came with about 3 foot of hose. And I don't know what this hose is made of. To me, it looks and feels and the way it crushes everything, it's telling me it's silicone, but there's no markings on it. So if anybody has an idea of what a good flexible hose is, 3/8 ID, please leave me a comment. Silicone is not recommended for natural gas or propane. Now, since this is just a short piece and I don't use these generators very much, I'll just keep an eye on this for right now until I can find either what that hose is or a better hose to put in there. Let's see. Some of you may be wondering, do you have to buy a conversion carb and use this demand valve? The answer is no. There's nothing special about this demand valve other than the fact that it came as a conversion carb. So it was just an easy way to get what I needed done. You can use a Gaseous KN demand valve that's very popular. You can use a demand valve from another generator, assuming it's as large as or larger than the generator you're modifying. This is just one way to go. And again, it's a cheap way because these conversion carbs are about 30 bucks. The Gaseous regulator, well, they're pretty pricey. The other thing is let's see. Oh, yes. I modified the spark plug wrench that came with the WEN generator. I took an old 13 millimeter 12-point socket that I had. I have no use for a 12-point socket anyway, but it fits in here, and I drilled a hole through it, and so now I can actually torque the spark plugs properly. I use 16 foot-pounds as my go-to torque. 16 to 18 foot-pounds is probably recommended, but I don't want to over-torque a spark plug accidentally in an aluminum head and end up with a big problem having to replace the head or do something else to it. So I always torque them, do 16 foot-pounds, and I've never had an issue. But you can't get a regular spark plug socket down in on this generator to the spark plug. You can't get it down there. It just won't fit because it hits the valve cover. So you have to use the wrench that came with it or do something different. All right, let's see. Of course, and don't forget your Loctite. Everything vibrates on these generators. It's just a good idea to keep parts from flying off to use Loctite. And if you do go with a different demand valve, you may have a question, does that need to be mounted to the carburetor? No. In fact, in most cases, demand valves are not mounted to the carburetor. They're mounted to the frame, and then there's a flexible hose that goes from the demand valve over to the carburetor. Now, this being all one assembly, as the engine vibrates, everything vibrates together. So there's no stresses being placed on any of this. So if you get a demand valve and mount it to the frame, just make sure that you use a really flexible hose between the demand valve and your carburetor because of the vibration, because the demand valve will be fixed in place and the carburetor will be vibrating like crazy. So if you use a really stiff hose, you're going to end up breaking something. All right, I think that sums it up, and we'll leave it at that.